So we'll go ahead and get started. I only have just a couple few slides anyway. Hopefully there's enough discussion either about the topic, or I'll just keep rambling on for a while. I felt that this is a presentation on cloud, so we need to talk a little bit about clouds. They're kind of nebulous. They're maybe a little ethereal. Sometimes they're even foggy, but the reality is that this is a really good way to think about clouds. People don't know what they're talking about, right? Everybody says, I want to build a cloud. That might mean I want to build applications. That might mean I want to do infrastructure. It really is all over the place. What we at Cisco have started to do, actually in conjunction with some work that Puppet Labs had started, and we just are sort of more of a development test help partner for them in certain cases, is we've actually looked at how you actually build the infrastructure for cloud class services. So infrastructure as a service tool sets. Specifically, we've been working with the OpenStack services solution for this particular model of building a cloud. And we're using Puppet to instantiate that entire cloud environment. Right? So if we look at the general process for what we've been doing, we start out with a build server. Some people will actually do this within an embedded switch type environment. Others will have an ISO that builds sort of a memory-based VM that goes and deploys clouds. We actually build a server so that we can have a Puppet master running to provide the infrastructure for the rest of that build out, and then have that consistent engine, so the tool set that Puppet provides to actually help us build and maintain and then eventually grow the cloud as well. From that initial build server, we've built out a couple key tool components to actually enable the deployment of the physical infrastructure behind that cloud. So we used IPMI as a way to signal power control into our rack servers. We actually have some XML-based APIs that also work against our UCS Blade servers. And then we used a tool called Cobbler to actually provide Pixie boot services. Those two tools are likely to be replaced shortly in this model with Razor. The Razor lab that we have running later this afternoon actually leverages that same UCS infrastructure that this was built out on, but uses Razor to actually deploy that solution. So those pieces are somewhat flexible and fungible. We've done this both with the Puppet Enterprise solution and the Puppet open source version of the environment, and we have a set of manifests and a whole pile of modules that we've gone through and validated against this deployment scenario. The Puppet modules and manifests, for the most part, are actually were baselined by Puppet Labs initially, and some of the community obviously had contributed quite a lot to that. We've been contributing back to that same thread. So basically, there's one central aggregated solution for the general modules and model for deploying OpenStack services on top. So once we have that baseline built out, so now we have our Puppet master, and in our case, we have a Cobbler instance to actually go deploy the cloud. We can actually then map that entire cloud onto a reference architecture. So we have a physical model reference architecture both for rack servers, and this is migrating and changing over time, obviously, as we learn more about it. We have a rack server model, we have a Blade server model, and right now one of the interesting things about the OpenStack services and the OpenStack cloud environment is the ability to leverage basically compute-based storage rather than separate storage arrays. Yes?
Since you're not using 6200s, these are standalone nodes?
These are, right, in this particular case, they're standalone nodes. That's where the IPMI tool connection comes in. Actually, there's an update to the systems BIOS within the C-series servers that would let us get rid of IPMI tool and use the same model that we're using against UCSM for power control and some of the other baseline configuration of the infrastructure. Right? And for those of you that aren't aware, UCSM is a tool that we have that works on rack servers with the right network services infrastructure on top, and also works on our Blade servers. And it provides basically a policy-based engine for mapping services and capabilities into those physical servers. So we can change some of the parameters of the infrastructure in that particular fashion. Anyway, so as we go through the chain, the infrastructure to actually power on and then build the actual operating system, again, we're using Cobbler for that piece so that we get a base operating system laid onto the system. We also then install Puppet Agent, and then Puppet takes over. And Puppet does really all the key magic here in deploying the services and solutions into the environment. Right? So from that perspective, the Puppet pieces are all fairly straightforward. It's a classic module model for actually doing that deployment. The real benefits that we're finding in doing this and following this process is that once we get the system up and running, OpenStack is still a fairly young project. And so we find that there are lots of times where we need to patch a component to actually make it function properly. And rather than doing that patch as a script on one node and then having to try to figure out how we replicate that, we can actually implement that patch as a Puppet module, as a Puppet instantiation, and then apply that to our environment. As we want to look at migrating that service from a running state to a new running state, we can actually do that through Puppet. So it becomes a very powerful, very flexible way of actually deploying the baseline infrastructure for the system. Right? So that's sort of the loop model, and actually a couple of the other pieces on here, if any of you guys have worked with OpenStack at all, there is no monitoring embedded into the OpenStack environment. So we've actually built additional extensions on top of the baseline for doing some simple systems level monitoring, tying it into Nagios, for example, collecting data on both the storage and the compute infrastructure, and then modifying the Horizon UI, basically adding in new modules into the UI. Again, using the same model, we write a Puppet manifest that actually modifies the running system state to add in those new modules in that new presentation component. So it's an incredibly powerful tool for just getting the infrastructure deployed, right? You know, one of the other reasons that we started looking at Puppet, because there are a lot of scripts for deploying OpenStack too. I mean, if you want to set up a node, yeah, sure, one script, you can get a single instance OpenStack up and running. But when you start looking at the interactions of all of the different pieces within the OpenStack systems environment, you start to realize that a script model is never going to scale. It's never going to be able to handle all of the different interactions, and especially the changes in interactions as we go from one version to the next, the changes in APIs. Making sure that these communications paths are all running and enabled at all times is really a key, and it's another area where the Puppet toolset really comes to bear. Right? So, any questions about sort of this level of the view? No? Okay. You guys want one of these? And actually, that's an important thing. You know, we've built a model for deploying this system. Right? We've leveraged the massive amount of work that the Puppet Labs team and the community has done in this space to actually establish this environment. We've defined a physical infrastructure reference design and architecture. Right now that's against both our rack servers and our blade server models. And we've posted all of this publicly, right? So Cisco is trying to be, as much as we can, a part of the overall community that supports both OpenStack and clearly supports Puppet as well. The site here, it's GitHub Cisco Systems. We have a number of our variants of the Puppet Labs scripts. Our variants are just the ones that we've gotten to the point of testing, right? So we try to keep as close to on track with that, and Dan's been managing massive amounts of changes that are coming into that environment. So we're often a little bit behind sort of the master from Puppet Labs. But we're trying as much as we can to keep that in sync, and hopefully at some point we'll actually get it to the point where we are fully in sync at all times. But right now we're just a little bit behind that. But what we've done with that is we've actually built out the sets of tools and scripts that allow you to, you know, do a single script install of getting at least an open source Puppet master up and running, getting in our case the cobbler components installed, and the base manifest that you can then go in and modify, do some minor modifications to actually establish and run that environment. So all of that is posted up here. There's some simple instructions along with that as well. This is similar but a little different than the instructions that are on the Puppet Labs OpenStack page as well. But so there are multiple ways of actually getting this thing accomplished. And as I said earlier, the Razor piece is something that we're hoping to inject into this environment as well. So pull cobbler out, put Razor in. So that's, I think, a real key piece of this. Any questions on that or where it is or any of the? You guys are good. Is this the right kind of information for you? I mean, or were you looking for something else? Yeah, good. Okay. So another thing is, you know, where are we going with this? So Cisco's a big company. We have lots of different projects and capabilities. We actually have a team inside, actually two separate teams right now. One that is more product and systems focused. We're doing modifications to the network services infrastructure, of course, because we are a networking company at our heart. But we're also looking at a number of the other sort of systems level components and actually looking at how we extend beyond just that infrastructure layer. Right? So some of the core systems level things that I think are really sort of front of mind in any kind of a systems deployment like this is high availability. Dan again sort of pulled a trick out of his hat a couple months back and built out, I guess with Nan's help, an HA model, or a first pass HA model, based on a reference architecture that the OpenStack community had presented. That model is useful. It's an active passive model with separate control nodes. It's actually useful, and it's a great way to see again how powerful that the Puppet extensions and ability to add on to a running system are, because we can take a standalone system and just by updating the site files basically enable all of the multi-node environment. Right, there's still some minor glitches in actually enabling that full path, but the possibility is there. So you can stand up a single instance environment, and while we probably still have to do some complete rework on a couple of pieces, you can actually migrate that to an HA active standby environment. What we're hoping to get to in the next sort of step is to actually get to a multi-way active environment. Again, the same sort of pieces apply. The Puppet tools allow us to sort of extend from a single instance model to everything on one node model to starting to break out compute, break out storage, break out the proxy services that are involved, out to an active control plane across multiple nodes as well. It's very powerful, and it's a key way that we're actually making this possible, because otherwise it would just never be something we could get to market with. Another component of this, I sort of touched on it just briefly a moment ago, is the assurances related tasks. Once I have this system stood up and running, Puppet is going through and doing its sort of semi-compliance class functionality, validating that the system is running. But we're also deploying additional services on top of that to do, CPU load monitoring, systems activity monitoring. Are our VMs actually running and providing the right class of information, and starting to collect that. And we're working with some other partners, folks like Xenos and the Nagios teams, to actually build better monitoring tools that also plug into OpenStack. And again, Puppetifying all the deployment process for those integrations. Right? So that's a key area. One of the things, like the GitHub site, is sort of our first pass at this, but we're actually trying to get to the point where we could have a single ISO with all of the base level pieces on it. That the ISO would be all open source, but as you look to go into production, obviously migrating to some supported services for things like going to Puppet Enterprise to actually have a supportable Puppet instantiation, going to Xenos Enterprise for the monitoring pieces. In a sense, our hope is that you would then use our infrastructure for supported infrastructure in that sort of an environment. But really making it possible to get that OpenStack infrastructure up and running, because we really do see that the infrastructure as a service model is the future for how I think people want to consume compute and data center infrastructure. So that's really why a key reason why we're doing this. And as I mentioned earlier, we are still a networking company at heart, and we see a massive gap in how people can talk to networks. The network models that most cloud class services enable right now are incredibly limited. And unfortunately, we don't even really have, I would say, great integration at the Puppet level with network service and network modeling and network automation. These are areas that we're also looking to extend and improve upon as we go forward. And really, that's what I had for slides. I don't know if there are other questions that I can address, or if there are other areas that you'd like some more information on in terms of what we're doing or how we're doing it. Yes?
In terms of monitoring, did you find limitations with the Nagios resource types with Puppet, or are you just choosing not to use them?
I think we are actually using some of those components. The things that we've done really were standing up specific variants of Monet and collectd on the hosts, and I think we are actually leveraging the Puppet tool set in that space. It's just that there are some additional services we really want to start tying into Xenos and the XenPack architecture too, and I don't know if you guys have looked at that. Yeah, I've got good friends there, so I keep in touch with them. But and actually, our organization. So I'm in the systems development unit. So again, we do these sort of top-level solution environments. We've already picked Xenos as an impact analysis tool for some of the services we're doing. So there's a secondary tie-in there from my perspective as to why Xenos is an important piece. But we certainly have not shied away from Nagios either. Right.
You monitor inside the instances as well?
So we have, I think we've extended we've got the configuration files for collectd to actually look at libvirt access into the VMs. That's as far as it goes. We're not at this point yet deploying things into deployed VMs. That's actually another piece. It's not something that's on my roadmap in any way yet, but it's something that I would love to see us be able to do. Is once we've got this infrastructure layer, I think the next thing is that application layer that sits on top. I know, again, Dan's done some work relative to Google App Engine kind of model. Hey, now that I've got an infrastructure service, maybe even a platform service deployed on top, I want to be able to monitor those and manage those systems in the same fashion, right? Leverage that same DevOps model. Right. Mm-hmm. Yes?
Have you run into any of the orchestration issues on top of Puppet? I mean, because there is obviously quite a bit of moving parts.
So far, what we've mostly done with Puppet is get the system deployed and stable. And at that point, there's not a whole lot of change that we're driving with it. we have the ability to drive that change. I think that's the biggest value. Yeah.
I would say that if you think about kind of OpenStack in terms of Glance and Nova versus Swift, with Swift there are definitely orchestration problems. But the OpenStack services are actually robust enough that it's probably better that controllers come up first, but in general, if things fail to connect, you just keep retrying, which makes it a lot easier. But with Swift, yes, true.
How are you solving it? I guess that's my question.
I would say that I have ideas about how it should be solved better than I have solutions right now.
By the way, we're looking to hire developers that want to fix that problem. I think it is everybody else, but yeah. So,
I mean, part of that is that stored configs or?
Well, stored configs on that front is being replaced with. PuppetDB is going to be the back end. So, sorry.
No, it's just good.
So if you think about service level orchestration for configuration management, there's actually two separate kinds of orchestration that you have to worry about. The first kind of orchestration is for data connectivity. If you're actually going to do dynamic discovery of services based on a central configuration database like PuppetDB, then now you have a problem where the services actually do have to come up in a certain order for that to be possible. And I have a good solution for that, which is I'm using basically query tools that I wrote on top of PuppetDB that hopefully I'll be blogging about and talking about soon. But basically you can do queries to say like connecting to a node controller. With PuppetDB you can write queries really simply to do things like give me the FQDN or the IP address _0 for all machines that have the class of node controller. And give me the actual parameterized class for that thing so that I can query out things like what is its port, how is it bound, and also I'm writing these as Puppet functions so you can do constraints as well. If I get more than one fail, given the criteria of fact filters to make sure it's in the right domain, if I don't get one fail. And since that's done as a function, it's actually a compile time failure. So we're just running in preceding a loop and saying while Puppet fails, meaning the other connectivity services aren't available, keep looping. So that's the first kind of orchestration problem. The second kind of orchestration problem is it's not only enough to know when the data is available in the central configuration management database, you actually need to know sometimes, and in the case of Swift right now is a three-phase run, because you actually have to configure the storage nodes and then update the ring builder before you can update the storage nodes. And I have actually had a lot of internal discussions at Puppet Labs, and we kind of have this vision for the future. But I think the solution for right now that I would like to implement when I get time, anyone?
Like I said,
basically simple resources that curl for dependent services, right? So, and then put that in the resource graph. So in Tool, I can do a TCP curl to this port. Just don't let the next resource resume. Put timeouts on those things. And it actually kind of winds up looking for people who have familiarity with CloudFormation. Like there's one little bit of genius in CloudFormation, which is the fact that it's a message queue based, like interconnection of dependencies. But I think that's the way to do it now. And one of the things on my queue that is not anywhere near the top is to redo Swift to actually do that. But this native resource type doesn't actually exist. But if someone wants to write, or is enthusiastic to write like a curl native resource type just for service level dependency management, like Dan at Puppet Labs, please let me know when it's done. I'd love to give it a shot.
Actually, this is definitely something that we're looking into as well, because again, I'm in the business of deploying Hadoop, but not for the customer. So I'm not a DevOps person, right? I'm actually building solutions to help DevOps people, deploy Hadoop. And this is definitely what we're looking into, because in my ideal world, I just realized, I really need inter-node dependencies, at the Puppet level, just like I have dependencies in the Puppet graph within a single node. So I want to be able to say, like, you need to depend, this resource depends on that resource. Well, they happen to be on different nodes, but so what, right?
And I would say as well that in the internal conversations that I've had with Ari and with various other folks, in terms of the technology that's available now, we talked about 3 strategies. One was using mCollective to broker messages, but mCollective is for distributing messages. It's not for reliable message passing, right? It's a message queue. It's not what it's used for. The second would be native types to interact with some remote key value store, something like Apache Zookeeper, but native types for interacting with the system. But it just seems like now you're still relying on some external service, which has to be available, it has to be implemented. But it seems like the reality, and also now you have to be connected to some other machine, which may be somewhere else, right? But it seems like the reality is that if I'm waiting for a database to come up, then I should be able to read something English, and I should be able to ping it around.
Well, we definitely need to talk some more.
Yeah, sure. I'll be up there.
There was another question.
So you described this talk as this a particular system running within Cisco for an internal Cisco community, or is this like a blueprint that's shared with sales engineers or whoever in deploying services for customers?
It's actually both. We have internally we have our WebEx team that's actually leveraging this class of model. There's a lot of back and forth. We're an outbound facing team, and my group specifically works with the field engineers and our customers to actually deploy OpenStack class services in this particular instance. I work in general cloud across all different domains, but so there's that piece. Our WebEx team is actually building out an environment based on OpenStack, using Puppet to manage the OpenStack deployment process and ongoing deployment services. We have our Cisco IT team. We have an internal cloud tool that currently is based on vCloud Director that's also migrating to OpenStack. But that team uses Puppet very heavily just for managing that environment, plus also some of the additional IT services that they implement. Right. So we use it in multiple different ways. And the code that we're using, the model that we're using is posted on GitHub right now. Yeah. We're working on getting a Cisco.com page to present it as well, so that people understand, yes, this is really a real solution that we intend to be able to support.
Cool.
All right.
Thank you.
Sure. Any other questions? Yes?
When you say you're looking to move towards Razor, what are the benefits that you see of Razor over the cobbler infrastructure you have right now?
Well, I mean, it's the whole fact-finding based deployment model, right? And you can do a little bit of that with Cobbler. You can have a Cobbler node or a node show up in Cobbler, but then actually automating the process of saying, okay, I have a node. What is it? How do I use it? What am I intending to do with it? There are no tools there for doing that, right? Cobbler is effectively a sysadmin tool for pixie booting a specific server, rather than a tool for managing the deployment of services in general. And where I see Razor being real useful is taking the exact same model, right, this set of interactions at the OpenStack layer that we found so useful. That same system model works at the base level. Hey, I just deployed 2 of our C240 class servers, which are effectively our storage front-end servers in this particular model. I want those to turn into storage servers. I don't want them to be, oh, it's just another compute node, turn on compute, because I just put $10,000 worth of storage in this box. Right? So I really want that to be a storage node rather than a compute node. Cobbler really doesn't have the tool set to really handle that. I can still say, hey, this is a C240, it is a storage node, boot it with Cobbler, but that's not really quite the same thing. Right? So I really do see that the Razor integration is going to simplify that overall deployment process. I still have a vision of, yeah, you have to build one machine, but every other machine you plug in just turns on and becomes the right thing. And I think Razor is the tool that will give us that piece of the puzzle, with Puppet giving us the, yes, let's get the rest of the APIs properly deployed and integrated into the OpenStack environment.
So you're talking about having like a gold image for each type of server that would be coming up?
Effectively, I mean, that's sort of a core part of it, but in the bigger reality, I think we're going to end up with the exception of storage nodes, most nodes are going to end up as just compute-centric nodes. Right? Whether they're a control node or a compute-specific node, something that's just part of your standard compute farm, I think they're all going to look identical. Right? So then it's more a matter of, hey, I need to have a pool of 5 machines that are providing control, plus if they have spare capacity, they can also provide compute. Right? So there's a sort of a resource systems model that I think is maybe somewhat missing in our current infrastructure models. And honestly, I really just haven't had enough time to dive into Razor deeply enough to understand whether it provides enough of that systems model to say, yes, it gives me these resource controls. What I've seen makes me very, very hopeful that what I think I need is there. If not, then hopefully we find the resources to fix it, right? So that's kind of the view.
And just for clarification, when you're talking about storage, are you talking about Swift or talking about Cinder?
Talking about both. I think principally we've been focusing on Swift, but I don't see any reason why the same class of storage model wouldn't work for Cinder. And actually, there's again that sort of orchestration chicken versus egg kind of model. If I can get to the control plane automation and active model I want my controllers to be VMs that can migrate. In order to do that, I need a storage array that is central to the system, but I'd like that storage array to be replicated. So it's like, which one starts first? That's still a trick, but I think we can actually at least define a process for how that happens. Maybe we'll eventually automate that process, but even if I can get one node built that builds the infrastructure across 3 or 4 other machines, gets that migratable system environment deployed, and then I can rebuild that machine as a control node because I've migrated that service onto a VM, then I think we're there, right? So that's the model. Right? Yes?
There's some new hooks in the M3s. You've got the EFI, and I think there's some flash storage.
Yeah.
Is there any, obviously it's very Cisco specific, but is there any opportunity there to move some of the boot stuff?
Yeah, so again, in my view, at least the compute stack of nodes, whether the compute or control, could very easily just boot off of that internal flash, because really what you want that system to be is just a hypervisor engine, right? And that can be a real stripped down version of CentOS or Ubuntu or what have you to run that, or even Zen Server for that matter. At least I think the open source hypervisor is the right approach to take in that particular layer, but I'm certainly not against VMware or any of the other services. God, I sound like a marketing guy. But so that is a piece of the puzzle. As I was saying earlier, the cobbler piece is currently we're using IPMI tool to actually talk to our non-UCSM enabled servers. The extensions in the BIOS, which I believe also work on M2s and M3s, will actually allow us to talk to those devices via XML messages. I don't know if it was fully RESTful yet, so it might be more of an RPC class call, but at least we can do things like discover some of the base infrastructure, and again, I want that to end up in Razor so that Razor can classify the nodes properly and understand what it is it's actually seeing. But that's an integration that obviously we would have to do and enable to make that more extensible that way. Okay. Okay. If there are no other questions, I'll be around the rest of the day. We have a little booth at the far end of the little floor downstairs. Thank you guys for coming.